Howdy IB, it's Ms. Kosh. This is another type of proof by induction, and this is the proving inequality. I find these to be the most difficult. So they require a certain level of math creativity, for lack of better terms. So I want to work the one in the book for you and then encourage you to go practice, and hopefully over the years, there have been some years where I taught this and other years where I just kind of skipped it. And then it just so happened that the years I skipped it were the years that it showed up on the IB exam. So anyway, I do the best I can, but these are tricky, and these definitely take some practice. So let's see what we can do as we get started here. So once again with induction, we always say step 1 is n equals 1 is true. Okay, so let's see, 2, so the left-hand side, 2 to the negative 1, well that would be equal, actually let's do it, let's not do left-hand side. Let's say something, let's write it this way, I forget. If I have 1/2 to the n, oh, and I'm plugging in 1. 1/2 would be equal to 2 to the negative 1. And this we're saying, okay, is that less than 1 over 1? Well, 1/2 is less than 1. And so that's a true statement. So that's kind of one way that we could verify that to be true. Step 2, n equals k. So we're going to assume that 2 to the negative k is less than 1 over k. So we're making that assumption. And so now in step 3, we want to look at n equals k plus 1. Okay, so for this one, we're going to say, well, this means that 2 to the negative k plus 1 has to be less than 1 over k plus 1. So, oh, actually, see these, I'm telling you, I'm a little bit more hesitant on these than I would like to be. Let me start again. So we have this, 2 raised to the negative k plus 1. Well, this we know to be equal to 2 to the negative k times 2 to the negative 1, which would be equal to 2 to the negative k, times 1/2. Okay, this, we know that 2 to the negative k is, so from right here, this 2 to the negative k, we know that that is less than 1 over k. Okay, so what we can do is we can say, well, this expression, hang on, that's a lot of pink. We can say that this expression right here has to be less than 1 over k times 1/2. Okay, so what I did here is I substituted this out for what I knew from before. So basically, that negative 2 to the negative k is less than 1 over k. I substituted out that 2 to the negative k, but I couldn't do like a direct substitution because we know that that's going to be less than, less than 1 over k. So then they're each getting multiplied by 1/2. Okay, so now what can we say? Our goal, sometimes that's helpful to write. Our goal would be that 2 to the negative k plus 1 is less than 1 over k plus 1. Well, right now we have that 2 to the negative k plus 1 is less than 1 over k times 1/2. Okay, so we need to somehow relate this part here with this part here. Okay, so let's see what we can do. Hang on, let me clean up the clutter. Oop, too much clutter. Okay. So what we can say here is, well, we know that k has to be, okay, hang on, I lied to you. So this is now equal to, that is now equal to 1 over 2k. Well, since we could say since k is an element of the positive integers. Now remember, from way back at the beginning, this is only going to be true for where n is an element of the positive integers. So that means k has to be an element of the positive integers. Since k is an element of the positive integers, 2k is going to be greater than or equal to k plus 1. Okay, try that. So if you plug in 1, you notice you get 2 is equal to 2. If you plug in 2, you get 4 is greater than 3. If you plug in 3, you get 6 is greater than 4. Okay, so this is a true statement. So we can say since k is an element of the positive integers, 2k has to be greater than or equal to 2k plus 1. So that means that 1 over 2k has to be less than 1 over k plus 1. Okay, since if this value here, if this value is bigger than that value, then 1 over that. So something that's big divided by 1 divided by something big is going to get smaller. So it's going to end up becoming 1 over 2k is less than 1 over k plus 1. Oh, goodness, I'm telling you, you're going to have to forgive my imperfections in this video. But basically, now our final, so what we have said here is that, so 2 to the negative k plus 1 is equal to 2 to the negative k times 1/2, which is less than 1 over k times 1/2, which is equal to 1 over 2k, which is now less than 1 over k plus 1. Therefore, we have proved what we need to prove. We had gotten to, that was our goal, that this right here would be less than 1 over k plus 1. Okay, see how that shows up in the goal right there? Therefore, we can conclude, well, what did we start with? We can conclude that 2 to the negative n is less than 1 over n for all n element of the positive integers. Okay, for whatever reason, I struggle with these more than any of the others. So we both need practice. So I'll go practice and you go practice, and we'll just keep our fingers crossed that we learn this if IB wants to ask us this on the test. All right, good luck.